So we'll start the session now. This is week 10 online live session for physical chemical processes for, for wastewater treatment. And this course is offered by Professor V.C. Srivastav from IIT Roorkee. And I am the TA for this course. I am Vaibhav Kabadwal. I am a PhD scholar at IIT Madras from the Department of Civil Engineering. And my discipline is environmental engineering. So, in today's lecture, we will study about advanced oxidation process, which is also called AOP. We will solve some MCQs and some fill in the blanks. Generally, AOP is used as primary, secondary, or tertiary pitch treatment. It is used as tertiary treatment. Different wastewaters which can be treated with AOP. Do you know any wastewater which is treated with AOP? So these are pharmaceutical, personal care products, endocrine disrupting chemicals, pesticides. So these are the wastewaters which can be treated with the help of AOP, Advanced Oxidation Process. So AOP is used for toxic recalcitrant organic compounds as well as microorganisms. How AOP removes the pollutant, we will see. So it degrades the pollutant and there is no secondary waste stream generated. We will see it further also that it degrades and there is no transfer change, there is no concentration of the pollutant, but direct degradation. And it doesn't produce any sludge also. In some cases it produces, but in many cases it doesn't produce any sludge. But it is costly. What are the products of AOP? So after mineralization or after the degradation, the products are carbon dioxide, water, and mineral acids. What is the purpose of AOP? What is the purpose of advanced oxidation process? So what we do, generation of highly reactive oxygen species such as hydroxyl radicals, this is written as OH radical like this, to oxidize organic contaminants to mineralized products such as water, CO2, and inorganic ions. Hydroxyl, hydroxyl radical is a powerful non-selective chemical. So this is powerful also and non-selective means it will oxidize all the pollutant. It will not be selective. Like, okay, a hydroxyl radical is a powerful non-selective chemical oxidant which acts very rapidly to a wide range of organic contaminants. So wide range is because it is non-selective. Can intermediate compounds formed during AOP be more toxic than parent compound? Yeah, yes, they can be. What are the properties of reactive organic species? These are the properties of reactive organic species. Highly reactive, highly reactive due to the presence of unpaired valence shell electrons, which makes it a very powerful oxidant. These species are these are unstable, so these are short-lived. These species are capable of breaking strong chemical bond in the presence of light. Steps involved in advanced oxidation process. What are the steps, please? So these are the three steps. Formation of strong oxidants like OH radical. These oxidants react with organic contaminants present in the wastewater, converting them into biodegradable compounds. The last step in the oxidation of these biodegradable intermediates leading to the complete mineralization in water into water, carbon dioxide and inorganic salts. What are the advantages of AOP? AOPs are superior to other treatment processes. These are superior to other treatment processes because compounds present in wastewater are degraded. These are degraded rather than concentrated or transferred into diffused phase. So, like if you remember about uh, carbon adsorption, so it was concentrated. So all the pollutant was not degraded, rather it was concentrated. And if we see like in other processes, it will be like if you want to remove some gases from the water, so it will be diffused into air. So, but in this case, it is degraded completely, thus preventing the generation and disposal of secondary waste material. So there is no secondary waste material in advanced oxidation process. Advantages of AOP. So further we have some elaboration of advantages. They have high reaction rates. So if the reaction rate is high, so less volume is required. And if volume is constant, then we can treat more volume of water or more discharge can be treated. They have the potential to reduce toxicity and completely mineralize organic contaminants. They do not concentrate waste for further treatment like methods using membranes or activated carbon adsorption discussed that we discussed already. They do not create sludge as in case of physical, chemical and biological processes. They do not create sludge. So sludge is a major, if sludge is formed, we have to manage the sludge. So that is also an issue. So in this case, we don't have to worry about the sludge. Their non-selective pathway allows for the treatment of different organics at the time. So they are actually non-selective. So we can treat many varieties of organic compounds can be treated at a time. What are the applications of AOP? So the applications are in treatment of petroleum hydrocarbons, aromatic hydrocarbons like toluene, benzene, xylene, phenols, they can be treated. Fluorinated hydrocarbons like TC, PC, vinyl chloride, etc. Dyes can be treated. Pesticides can be treated. Pharmaceuticals can be treated. Explosives can be treated. Photocatalysts. Photocatalysts are conductors, semiconductors, or insulators. What are these things? These are actually semiconductors. So, what are semiconductors? Semiconductors, you might have studied earlier. So, this is valence band, this is conduction band. So, there is a gap exists between these two bands. If the gap is, we'll see it later. If the gap has a range of this much electron volt, then we can say it is a semiconductor. So photocatalysts are semiconductors, not generally specifically semiconductors. What is photocatalysis? Photocatalysts photocatalysts are materials that change the rate of chemical reaction on exposure to light, known as photocatalysis. Reactions that take place by utilizing light and a semiconductor. The substrate that absorbs light and acts as a catalyst for chemical reaction is known as photocatalyst. In this phenomena, an electron-hole pair is generated on exposure of a semiconducting material to the light. What are the two types of photocatalytic reaction? So there are two types of photocatalytic reaction. One is homogeneous, another one is heterogeneous. So let's see what happens in the homogeneous. When both the semiconductor and reactant are in same phase, when both semiconductor and the reactant are in the same phase, that is gas, solid or liquid, such photocatalytic reactions are termed as homogeneous photocatalysis. But when both the semiconductor and reactants are in different phases, such photocatalytic reactions are classified as heterogeneous photocatalysis. When the semiconductor and the reactant are in different phases, so these reactions are called heterogeneous photocatalysis. What is the band gap in semiconductors? So this I told, this is the conduction band, this is the conduction band, this is the valence band, and if the light will fall over photocatalyst, the electron will get excited, the electron will excite and it will jump from valence band to conduction band. So there is a band gap. So this band gap is zero in terms of metals. These are actually good conductors of electricity, and so it is zero. But for semiconductors, this band gap is in the range of 1.5 to 3 electron volt. This is for semiconductor. What is the catalyst in the Penton process? Iron is the catalyst in Penton process. The Penton process involves the generation of hydroxyl radicals through the reaction between hydrogen peroxide and, it is the same question, but the statement has been changed. That the Penton process involves the generation of hydroxyl radicals through the reaction between hydrogen peroxide and iron. The Penton process is widely employed in wastewater treatment for the degradation of various organic pollutants including dyes, pharmaceuticals, and pesticides. The Penton process can be enhanced by the addition of dash dash to improve the efficiency of pollutant degradation. The Penton process can be enhanced by the addition of catalysts like iron salts and inorganic ligands, like catalysts like iron salts and organic ligands. So if we add these substances, our efficiency can be improved. The Penton process is considered environmental friendly as it does not produce what we discussed. It doesn't produce any toxic compounds and sludge. It does not produce. The Penton process is considered environmental friendly as it does not produce any toxic substances or harmful compounds. Toxic sludge or harmful byproducts. Which condition is favorable for the Fenton process? Which condition is favorable for the Fenton process? Acidic or basic? So, basic conditions are favorable for Fenton process. Sorry, acidic. Acidic process. Acidic processes are favorable for the Fenton process. What is extended Fenton process? What is extended Fenton process? So the effectiveness. So this is the explanation of extended Fenton process. The effectiveness of the Fenton process can be improved using external non-chemical energy sources such as ultraviolet light, electrical current, and ultrasound. The effectiveness of Fenton process can be improved using external non-chemical energy sources such as ultraviolet light, electrical current, and ultrasound. Which oxidant is used in Fenton process? Think which oxidant. Which oxidant did we use in the Fenton process? So we use H2O2, that is hydrogen peroxide. For the oxidation, it is used as an oxidant. Homogeneous Fenton process make use of gas as a catalyst. Homogeneous Fenton processes make use of which thing? Iron 2 plus and iron 3 plus in aqueous. Iron 2 and 3 in aqueous as a catalyst. So homogeneous means both will be in the same phase. So the catalyst and the water are both in aqueous phase. So when both are in the same phase, this is called homogeneous process. When Fenton process occurs in the absence of light of suitable wavelength to cause photoreduction of iron 3 complexes, they are called. When Fenton process occurs in the absence of light of suitable wavelength to cause photoreduction of iron 3 complexes, they are called dark Fenton process or thermal Fenton process. It is called dark Fenton process and or thermal Fenton process. Heterogeneous Fenton processes make use gas as a catalyst. Gas as a catalyst. So what Fenton homogeneous Fenton processes make use of gas as a catalyst. So what is this? So these are heterogeneous. So in heterogeneous process we use solid Fe2 plus or solid Fe3 plus as a catalyst. What are different non-chemical energy sources used in extended Fenton process? What are different non-chemical energy sources used in extended? So different non-chemical energy sources are ultraviolet, UV light can be used, microwave can be used, gamma radiation can be used, ultrasonic radiation can be used, electrical energy can be used for non-chemical energy sources. In so these are so in extended Fenton process, these are the non-chemical energy sources. What is Fenton-like process? So this is not, read it again. This is what is Fenton-like process. Fenton process is different, and Fenton-like process means it will look like a Fenton process, but it will not be the Fenton process. So a wide variety of other when a wide variety of other trace metals can also react with H2O2 to yield useful reactive oxidants. Read it again. When a wide variety of other trace metals can also react with H2O2 to yield to yield useful reactive oxidants, which may or may not be OH radical. So they are saying like we can use different instead of iron we can use other trace metals. We can use other trace metals plus H2O2. But instead of OH radical, we can get other radicals. We can get other reactive species. These are called Fenton-like processes. What are commonly used trace metals in Fenton-like processes? Commonly used trace metals. So these are the commonly used trace metals in Fenton-like processes. This is copper, cobalt, manganese. This is titanium. Multiple objectives of using ozone in water treatment. So what are the multiple objectives of using ozone? So ozone can be used as a disinfectant. So it can be used for disinfection, and it can also be used to reduce taste and odor, because it will oxidize the organics which impart taste and odor. It can also be used in reducing the formation of disinfection byproducts, oxidizing organic contaminants. So for oxidation of organics, the ozone can be used. What makes ozone highly reactive and unstable toward a wide variety of water constituents? So the question is, what makes ozone highly reactive and unstable? Highly unreactive and unstable toward a wide variety of water constituents. The electron density. So this is because of the electron density and distribution across the ozone molecule causes it to be highly unstable and reactive towards a wide variety of water constituents. So the electron density and its distribution, the electrons and its distribution makes it highly unstable and reactive towards wide variety of water constituents. What are the two common ozone-based AOPs? What are two common ozone-based AOPs? So, two common ozone-based AOPs are with hydrogen peroxide. Ozone can be used with hydrogen peroxide, H2O2. So, this is called peroxone process. Peroxone. Peroxone process. And another one is photolysis of ozone with UV. So when ozone is used with OV, it is called photolytic ozonation. Photolytic ozonation. The main electrochemical water treatment processes include, so electrochemical water treatment. So these include electro-oxidation, electrocoagulation, and electroflotation. How electrocoagulation can be done. Electrocoagulation, like coagulation, is the process of destabilization. It is the same process as coagulation. So electrocoagulation, like coagulation, is the process of destabilization. Destabilization means when particles do not come in contact with each other, so we provide the coagulant so that they can come in contact with each other and make a flock and they can settle. So this process is called destabilization. So in is the process of destabilization of colloid particles present in wastewater and can be achieved by the two mechanisms. So here two mechanisms are written. So one, in which an increase in ionic concentration reduces the zeta potential and adsorption of counterions on colloidal particles, neutralizes the particle charge. Other well-known mechanism of sweep coagulation. So one, in first case, we will increase the ionic concentration so that it will reduce the zeta potential and the particles will have more. The particles will be neutralized and the particles have more chances of destabilization. Second one is sweep coagulation. What are the steps of electrocoagulation? Some issues here. What are the steps of electrocoagulation? So now it is fine. What are the steps of electrocoagulation? So first one is anodic metal dissolution. Anodic metal dissolution. Then formation of hydroxo complexes. Third is particle destabilization. Fourth one is particle aggregation and sedimentation. So what are these steps? Anodic metal dissolution. So this will the anode material will be dissolved into the anode. In anode, oxidation occurs. In cathode, reduction occurs. So what will happen? Anodic material will get oxidized. So it will form Al3 plus and Fe3 plus. So this will form AlOH3 hydrocomplex AlOH3 that will act as a coagulant. So in this case, the coagulant is formed using, we are supplying electricity. So that's why it is called as electrocoagulation. And in the next step, third step, particle destabilization will occur and then particle aggregation and sedimentation. We are aware of third and fourth steps. So the important thing here is first and second step, which I explained. The energy consumption in kilowatt hour per meter cube during electrocoagulation process can be estimated using the equation. What is the equation? The energy consumption during electrocoagulation process can be estimated using the equation. So this is the equation. The equation for energy consumption is, it is actually meter cube. Kilowatt hour meter cube. The energy consumption is UIT by V, where U is the applied voltage, I is the current intensity, applied voltage in volts, I is the current intensity in ampere, T is the time of electrocoagulation in R, V is the volume of treated solution in liters. So the formula is UIT by V. V is the volume of treated solution. The formula is UIT by V. The final quality of treated water during electrocoagulation is influenced by the final quality of treated water during electrocoagulation is influenced by the anodic material. Because here what we discussed in the last and the previous questions, like anode material is made up of aluminum and iron, so it will get oxidized and it will form hydrocomplexes with water. So that if you choose different anode materials, you will get different quality of treated water. And what is the distance between anodes? That will also affect the quality of treated water. Water flow rate in the inter-electrode space, and what is the temperature, what is the pH, anionic and cationic composition of the medium. So what are the anions and cations present in water, and what is the current density? So current density is defined as J, that is equal to current per unit area of electrode. Its unit is generally ampere per centimeter square or ampere per meter square. The electro-oxidation process depends on choice of an electrode plate, choice of an electrode plate, choice of an electrolyte, choice of temperature, concentration, pH, stirring speed, and composition of electrolyte in the solution. That means conductivity. So what is the composition of electrolyte is defined in terms of conductivity. Choice of two other different parameters, like what is the cell potential and what is the deposition of current. Parameters which influence the size of generated gas bubble. So the parameters which influence the size of generated gas bubbles are the parameters which influence the size of generated gas bubbles are the size, the properties of the electrode surface, the shape of the electrodes, pH, temperature of the medium, the surface tension of the electrode solution interface, the current density. So these are the parameters which influence the size of generated gas bubbles. The next question is, which is not a classification of advanced oxidation process. Of advanced oxidation process. So let's see one by one. So photochemical, yeah, it is the advanced oxidation process. Penton is also advanced oxidation process. Electrochemical is also advanced oxidation process, but sedimentation is not a classification of advanced oxidation process. Which of the following is a highly reactive oxygen species generated in the advanced oxidation process? Which of the following is highly reactive oxygen species generated in the advanced oxidation process? So, whether it is hydroxyl radical, potassium, bromide, NaOH, HNO3. So if you see the value, hydroxyl radical is a highly reactive oxygen species in AOP. Dash is a phenomenon in which an electron-hole pair is generated on exposure of a semiconductor material to light. So if you expose the semiconductor material to light, or Hc by lambda, so this is the energy. So is a phenomena in which the electron hole pair is generated on exposure to a semiconducting material to light. So this is photocatalysis. So photo means light and catalyst is used. So this is called photocatalysis. When both the semiconductor and reactant are in different phase such that the photocatalytic reactions are termed as heterogeneous photocatalysis. When both semiconductor and the reactant when both the semiconductor and the reactant are in different phase, then photocatalytic reactions are termed as heterogeneous. The energy difference between the valence band and the conduction band is termed as, so this is the valence band, conduction band. So this gap is called as band gap. Holes are something else. Photons are used in photocatalysis. Wavelength is which will fall over the photocatalyst like this. Hole is the vacancy created when an electron leaves the valence band. So when an electron will leave from valence band to conduction band, so a hole is formed and here the electron will go. This is hole. Photocatalysts provide not only oxidation but also reduction environment. Correct, true. So photocatalysts not only do oxidation, they also help in reducing oxidation. What is possible when the redox level of the substrate is lower than the conduction band and higher than the valence band? They're asking like this is valence band, this is conduction band. So if it lies between this band gap, then reduction and oxidation is possible. So let's see what the question is saying. What is possible when the redox level of substrate is lower than the conduction band? So it is lower than the conduction band and higher than the valence band. So both reduction and oxidation of the substance takes place. So both will take place. So both oxidation and reduction will take place. Which is a Fenton reagent. So here Fenton reagent is Fe2 plus and hydrogen peroxide. So this is Fenton reagent. So B is the correct answer. Dash process in which buoyant gases bubbles generated during electrolysis take along with them the pollutant material to the surface of the liquid body. Read the question again. Dash process in which buoyant gases bubbles generated during electrolysis takes along with them the pollutant material to the surface of the liquid body. So in this process, so what is this process? This process is flotation. So the gases will take the pollutant along with them. So this is electroflotation. Which is peroxone process? Peroxone process is O3 and H2O2. This is peroxone process. Thank you.